All right, today we're going to start Unit 3.2, and we're going to talk about how to solve a quadratic equation by graphing. All right, so first thing, just a reminder, quadratic function is a second-degree polynomial whose graph, again, is a parabola. That second degree just means that the highest exponent is 2. All right, in standard form, ax squared plus bx plus c equals 0. That's just a common form of a way to write a quadratic equation. All right, a, b, and c need to be integers, so no fractions, no decimals. They can be positive or negative, and a cannot be 0. B can be 0, c can be 0, but a cannot be. All right, so the first thing we're going to look for are what we call roots. And roots are the solutions of a quadratic equation. And one method for finding the roots is to find the zeros of the related quadratic function, and the zeros of the function are the x-intercepts of its graph. All right, so all of these words that I just wrote in the blanks here are interchangeable. They all mean the same thing. Roots, solutions, zeros, x-intercepts, they all mean the same thing. All right, so the easiest way to find these is by graphing the equation and then looking for the x-intercepts. So we're going to solve x squared plus 6x plus 8 equals 0 by graphing. All right, and so the way to do that is to use the related equation f of x equals x squared plus 6x plus 8. All right, so basically we're changing that 0 to f of x. So we can make a table, xy. We're also going to need to know our axis of symmetry. So axis of symmetry is x equals negative 6 over 2 times our a of 1. So negative 6 over 2, negative 6 divided by 2 is negative 3. So our axis of symmetry is negative 3. Our vertex then is going to have an x value of negative 3. Now we need to figure out the y value, so run negative 3 through our function. Negative 3 squared plus 6 times negative 3 plus 8. All right, so negative 3 squared is 9. 6 times negative 3 is negative 18. 9 minus 18 is negative 9. Negative 9 plus 8 is negative 1. So our vertex is at negative 3, negative 1. So we go ahead and place that there. We have, next thing we can do is y-intercept is at 8. Our graph doesn't go up to 8, so we're not going to need to be able to use that one. Our graph only goes up to 6, so not going to worry about the y-intercept, graphing that. So the next thing we're going to do is just find some x values or y values, or x values to the left or right. I got negative 4, negative 5, I got negative 2, negative 1. And just plug those in to our function and see what happens. So negative 5 squared plus 6 times negative 5 plus 8. So negative 5 squared is 25. 6 times negative 5 is negative 30. 25 minus 30 is negative 5. Plus 8 is 3. And then negative 4, run negative 4 through the function. So it's going to be 16 minus 24 plus 8. 16 minus 24 is negative 8. Negative 8 plus 8 is 0. All right, and then I can mirror the other side. So we have points at negative 5, 3, negative 4, 0, negative 3, 1, of course, negative 2, 0, and negative 1, 3. All right, so we can go ahead and draw our parabola on our graph here. And it's going to look something like that. And now we can solve this because there are two Solutions. This graph has two real solutions since it has two zeros, and they are found at -4 and -2. Now, that is one of the possibilities when we're graphing a quadratic. It's also possible that there is one real solution, and that is found whenever we have our vertex on the x-axis. If our x-intercept is also the vertex, there is one solution. So if the x-intercept is the vertex, that is the way we have one real solution. And then it's also possible they have no real solutions. All right, so it's possible that our vertex is above the x-axis and opens up, or it could be below, our vertex below the x-axis and it opens down. And so there's nowhere that it crosses the x-axis, so there would be no solutions. All right. So that's it for that page. So let's move on here. Solve x squared minus 4x equals -4 by graphing. Well, the first thing I have to do is get it equal to 0. So I need to add 4 to both sides. Get x squared minus 4x plus 4 equals 0. And that's the one I'm going to graph. All right, so now that I have that, now I'm going to graph y equals x squared minus 4x plus 4. So to find my axis of symmetry, it's going to be x equals -b, so +4 over 2 times 1. So +4 over 2, so that's going to be 2. So my axis of symmetry is going to be at the x value of 2. I'm going to plug that into my formula, my function. 2 squared minus 4 times 2 plus 4. So that's going to be 4 minus 8 plus 4. 4 minus 8 is -4. -4 plus 4 is 0. So my vertex is on the x-axis. So 2, 0. Come up with points to the left and to the right. All right, so let's see, 0 squared is 0. -4 times 0 is 0, so that's just going to be 4, and that'll be 4. And then 1 squared is 1. -4 times 1 is -4, so 1 minus 4 is -3. -3 plus 4 is 1. So I can go ahead and graph those. And there we go. And go ahead and draw that graph on there. And I have one solution. It is that vertex. So the equation x squared minus 4x equals -4. The only solution is x equals 2. All right. A lot of times our x-intercepts are going to be between whole numbers, and it's hard to tell exactly where they are. We can estimate, though, by stating the integers between which the roots are located. So when the value of the function is positive for one value and negative for a second value, then there is at least one 0 between them. So let's look at the table here that we've been given. We've got x values of -3 through +3. Then let's look at the y values, or the f of x. All right, so our f of x goes from 12 to 3 to -6 to -2, and then back to 4, 8, and 14. So look, it's crossing from positive, and then right here, between 3 and -6, at somewhere in there, it crosses from positive to negative. And that means it goes across 0. So that means our solution, one of our solutions, is somewhere, so x is between -2 and -1, and then going from negative to positive, So we got negative, negative, and then back to positive. So somewhere between 0 and 1. So that's where our x's have to be, our solutions have to be. All right. The other way of solving a quadratic is just by making a table. We don't even have to graph it. We can just make a table. You can do it a horizontal table like in the previous example. You can do a vertical table. It doesn't matter. If we figure out our vertex, that'll go in the middle of our table. So our vertex is going to be positive 1 over 2, so 1/2. And then if I run 1/2, that's going to be 1/4 minus 1/2 minus 10. All right, so 1/4 minus 1/2, so that's negative 1/4 minus 10, so that's negative 10 and 1/4, or negative 10.25 if you prefer. Then I'm just going to pick some whole numbers to the left or right. So if go with 0, negative 1. We'll go with 1 and 2. See if we can't figure out where some zeros are. So if I run 0 through the function, I get negative 10. And so obviously if I run 1 through the function, I'll get negative 10. Let's see, if I run negative 1 through the function, negative 1 squared is 1. Minus negative 1, so that's going to be plus 1, so that's going to be 2. 2 minus 10 is negative 8. That'd be negative 8. Then let's see, if I go to negative 2 or 3, I'll do 3. 3 squared is 9. 9 minus 3 is 6, and 6 minus 10 is negative 4. So still haven't crossed over into positive land yet. So let's go with 4, and that'd be negative 3 up there. So 4 squared is 16. 16 minus 4 is 12. 12 minus 10 is 2. So just check and make sure. Negative 3 squared is 9. 9 plus 3 is 12. 12 minus 10 is 2. All right, so somewhere between negative 3 and negative 2, it's crossing from positive to negative. So somewhere in here, it crosses from negative to positive. And somewhere between 3 and 4, it crosses from negative to positive as well. So that is all there is to it. So, all right, if you have any questions, please shoot me an email. I'll get back to you as soon as I can, or Canvas message.